Today we're going to be working with this idea of graphing still. However, we've been only able to graph if something's written in slope-intercept form. Right? Slope-intercept form. That's the only way we know how to graph. If it says y equals mx plus b, right? Or if it said x plus 4, or x equals 4, or y equals 2. Or it said y equals mx plus b. This is the only way that we know how to graph from. Right? If y is alone or if x is alone, then we can graph. We know what we're doing, right? We can do our slope. We can start at our y-intercept and from there count our slope and we're good to go. Then last week we also learned about this thing called standard form. And standard form was ax plus by equals c, where x and y are on the same side of the equal sign. X and y are on the same side of the equal sign. However, the problem with standard form is that up until now, we don't know how to graph it. So there are two ways of graphing something in standard form. We can solve for y, meaning get y alone, which is totally doable. Or we can use this idea of x and y intercepts. And I know that most of you out there are going to say, Mrs. Long, if I have a problem, 3x plus 4y equals 12, and you want me to graph that, I can't identify the slope in the y-intercept because it does not look like slope-intercept form. It does not have y alone. It's in standard form. X and y are on the same side. So we have two choices. We have two choices when it comes to standard form. Choice number one is to change to slope-intercept form. Which is totally doable. So if you had 3x plus 4y equals 12, if we're changing to slope-intercept form, that means we're solving for y, right? Because slope-intercept form is y equals mx plus b. Y equals mx plus b. So if I was going to solve 3x plus 4y equals 12, if I was going to solve that for y, meaning get y alone, pretend that just said 3 plus 4y equals 12. What would you do if that problem said 3 plus 4y equals 12? Minus 3. So we're going to subtract 3x, because that's what our problem says. And 3x minus 3x cancels out. What are you left with? What's left on the left side? What's left over on the left side? 4y equals, can you do 12 minus 3x? No. How do you write it? You could write 12 minus 3x. What's a better way? Negative 3x plus 12. Am I done? Is y alone? It is?
No.
No, what's still with it? Divide by 4. Four divided by 4 cancels out, and I'm left with y equals, and then we draw this ugly heart. What's negative 3 divided by 4? Do you know? It's a decimal. Do we want decimals in slope-intercept form? So I'm going to leave it as a fraction, negative 3 over 4 x. And 12 divided by 4 is positive, so plus 3. Could you graph that now? What's the slope? Negative 3 over 4. Where does the graph start? Where's the y-intercept? Up 3, right? Plus 3. Now, I'm going to go out on a limb, and I'm going to guess, changing to slope-intercept form, you're not a fan of it. So there's a second choice. Which is what we're working on today. Can we draw attention to it? This is what we're going to do. You could use x and y intercepts. We talked about y-intercepts earlier, didn't we? What is the y-intercept? What does y-intercept mean? It was on your bell work last week. Y-intercept. Y-intercept. It's also in your notes. We defined it in previous pages. Y-intercept. Eduardo? Yeah, where the graph of the line crosses the y-axis. So we're going to find the y-intercept, and we're going to find the x-intercept. We're going to find the x-intercept and the y-intercept. We're going to figure out where the diagonal line crosses the x-axis and where it crosses the y-axis. So to do this, we're going to substitute 0 twice. To find the x and the y-intercepts, you substitute 0 twice. To find the x and the y-intercepts, you substitute 0 twice. What does that mean? It means substitute 0 for x, and then we're going to do it again, but this time we're going to substitute 0 for, what do you think? Y. We're going to do this twice. So in the equation that you're given, you're going to substitute 0 twice. One time you're going to substitute 0 for x, and the second time you're going to substitute 0 for y. This is if it's written in standard form. If your problem is written in standard form, ax plus by equals c, we're going to substitute 0 twice to graph it. We're going to find the x and the y intercepts. So if my problem is 3x plus 4y equals 12, I'm rewriting it so that we can actually see it. I'm going to put 0 in for x. So I'm going to do 3 times 0 plus 4y equals 12. What's 3 times 0? 0. So do I even need to write it? So I get 4y equals 12 because 3 times 0 is 0 and it disappears. What does y equal? How'd you figure out 3, Sam?
4 times 3.
Yeah, you divide by 4, right? So y equals 3. The y-intercept is 3. The first time I substitute 0 for x. The second time, what am I going to do? Substitute 0 for y. So I'm going to rewrite the problem again. This is, I understand, not something that you need to do every time, but these are our notes, right? So this time, instead of substituting 0 for x, I'm going to substitute 0 for y. So 3x plus 4 times 0 equals 12. Does the 3x change? 3x, what's 4 times 0? 0, so do I even need to write it? Equals 12. I'm going to divide by 3. So x equals what? 4. Those are my intercepts. Now I can graph it. Draw a graph. Go to 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right, my y-intercept was y equals 3. So I'm going to put a dot at y equals 3. Where does y equal 3? Up 3. 1, 2, 3. This is not a line that I'm making. It's just an intercept. Right? So I'm not going to make a horizontal line. This is just the intercept. I'm solving for an intercept because my problem is 3x plus 4y equals 12. So my intercept, my y-intercept is 3 because I solved for 3. What's my x-intercept?
4.
So where does x equal 4? To the right 4. 1, 2, 3, 4. And there's my line. Now let's check because we did slope-intercept form, right? So let's see, does this graph match this graph? Are they the same? Does solving for y, changing it to slope-intercept form, give me the same answer as finding my x and y intercept? So let's look. This graph starts at 3, so I'd go up 3. That's a good start, right? And then my slope is negative 3 over 4. What does that look like? Down 3. Which way over? Right 4. Did it work? So they both give me the same solution. You have two choices if you're given something in standard form. Two choices. You could solve for y. You could put it in slope-intercept form, all of the algebra. Or you could do x and y intercepts, meaning substitute 0 twice. Substitute 0 for x, substitute 0 for y. Intercepts is faster, right? All right, let's try some stuff. All right, slow x and y intercept practice. Find the x and y intercept. You don't need to graph it yet. You're just finding them. Test it out. So for number 1, I'm going to substitute 0 twice. So I'm going to do x first. So 2 times 0 minus 5y equals 20. What's 2 times 0? So it cancels out. It disappears, right? And I'm left with negative 5y equals 20. I divide by negative 5, which I understand you could do mentally. You don't have to show your work necessarily. Equals what? Negative 4. The first intercept is negative 4. The y-intercept is negative 4. So I substituted 0 for x. Now I'm going to substitute 0 for y. So 2x minus 5 times 0 equals 20. Does the 2x change? What's negative 5 times 0? 0, so it cancels out. So do I need it? Uh-oh, I'm frozen. 2x equals 20. Two x equals 20. We're back online. Divide by 2. So x equals 10. So could you graph this? How would you graph it? You'd go down 4 and put a dot. And to the right 10 and put a dot and then connect them. And there's your graph. All right, let's try this one. You have two things. Is this written in standard form? No, but can you make it written in standard form? You can rewrite it, and that's fine. You don't really have to. I mean, you don't really have to. You could still substitute 0 and substitute 0. It's just going to be a little bit more work. But you'll still get the same answer no matter what if you substituted in this exact equation or if you made the decision to move (3x) to the other side. Because if you move 3x across the equal sign, you have to change it to negative 3x. Because whenever something moves across the equal sign, you do the opposite. Inverse operations move things across the equal sign. If it's positive, it changes to negative. If it's negative, it changes to positive. All right, so then I'm going to substitute. I'm going to put 0 in for x and 0 in for y. 15 equals negative 3 times 0 plus 8y. 15 equals negative 3 times 0 is 0, so I don't need it. 15 equals 8y, correct? I'm going to divide by 8. Divide by 8. What's 15 divided by 8? 1.875?
Yeah.
So y equals 1.875. That's okay. Decimals happen every once in a while. You'll be okay. I promise. Then we're going to substitute 0 in for y. 15 equals negative 3x plus 8 times 0. 15 equals negative 3x. 8 times 0 is? 8 times 0 is? So it just disappears, yes? Divide by negative 3, divide by negative 3. X equals what? Negative 5. I mean, could you graph this? Yes. You would go up how many? Almost 2, correct? It'd be a little bit below. You'd have to estimate. Again, it happens every once in a while. And then you would go where for this one? To the left 5. All right, I want you, number 3. Find the y-intercept. Find the y-intercept. Find the y-intercept, meaning y equals what? Find the y-intercept. Y equals what? Find the y-intercept. Y equals what? Find the y-intercept, meaning y equals what? Find the y-intercept, find the x-intercept. And then I'll give you one last one to do. To find the y-intercept, you want the y to stay, so you have to make the x disappear. 10 times 0 minus 2y equals 32. 10 times 0 is 0. Negative 2y equals 32. What does y equal? Negative 16. To find the x-intercept, what do you make disappear? The y. You want x, you want to solve for x, so you keep the x. 9x minus 13 times 0 equals 27. Negative 13 times 0 disappears. So 9x equals 27, yes? Divide by 9, what do you get? X equals 3. Number 5's a little bit harder. Because what's wrong with number 5?
There's no X.
There is no X written. Is there an X? Could you rewrite it like this? 0x plus 4y equals 72. Now can you solve for x and y? Yeah. 0x plus 4y equals 72, yes? Substitute 0 for x. So 0 times 0 equals, plus 4y equals 72. Yeah? What does y equal? What's 72 divided by 4?
18.
And the second, what's the x value?
0.
Yeah. If I put in 0, right, for y, my x-intercept is 0. It's going to be at the origin. My x-intercept is at... No, it's not. You guys lied to me.
What?
Nuh-uh. You guys fibbed. believed you. 4 times 0 is, so it disappears, correct? 0x equals 72. What are you going to do? Divide by 0. Can you divide by 0? So is there an x-intercept? Because what kind of line is it? If there's only a y value, what kind of line is it? It's a horizontal line. It's not an undefined line, right? It's a horizontal line because there's only a y equals, which makes sense. There's no x-intercept on a horizontal line.